Hello, ladies and gentlemen. Welcome to your final full day before turkey break. We are going to, instead of pushing a new idea, new concept, simplifying before multiplying is a very large concept to swallow and understand. And it's like that every year. And I have all the confidence in the world that when we continue to work with it, it's gonna just make sense. Okay, so be patient with yourself. Make sure you're still putting in the work, and eventually you will just get it. So for my challenge questions, we are going to look at simplifying, adding fractions, and subtracting decimals, which you've already done, right? Because you watched this video when you are completely finished with the challenge questions. So let's get into checking those challenge questions so you understand the mistakes that you made. If you made mistakes, maybe you did not. All right, so first we're going to simplify. We have 5/15. What this means is we want to find equivalent fractions that way. We want to find the smallest equal fraction. And the way you do that is you look at 5 and 15 and you say, what do they have in common? What do those two numbers have in common? Well, we look at their factors, okay? The way that I like to explain factors is if this was money, okay, and which dollar bills could be used to count to 5? Well, really, and you're allowed to pretend there's a 2 and a 3 and a 4 and a 7 and a $6 bill for this idea, right? So a 5 has, you can use a 1, you can't use a 2, you can't use a 3, you can't use a 4, and you can use a 5. Those are the only two numbers I can count by to make a 5. Now, what about 15? 1, 15, 2, no, 3, yes, and 5. So 1, 3, 5, and 15 are the only numbers I can count by for 15. So the question is, what is the biggest one they have in common? And that answer is 5. So that's my magic number. My magic number is 5, and I'm going backwards. So what was the original fraction, or the smaller equal fraction, that would use 5 as a magic number? What times 5 is 5? 1. What times 5 is 15? 3. So therefore, 5/15 simplifies down to 1/3. So that answer is 1/3. What about 25/30? 25/30. And what I just did is I showed you the example for the one punch knockout, right? That was the greatest common factor that we found. For this one, we could take our time and find the greatest common factor, or we could just look at it and say, look, ends in a 0 and a 5. What do you know about ending in a 0 and a 5? It's going to, they both can be counted by 5s to get to. So we could use 5 to find that fraction right now without figuring out whether or not it's the biggest one. Or we could take our time and figure out if it's the biggest one, okay? I'm gonna choose you the jab, I'm gonna show you the jab, jab, jab. And sometimes, a lot of the times with the jab, 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 one jab knocks it out. Let me show you. Looking at this, you know 5 is a number that goes into both of them. So instead of wasting my time figuring out all the factors, I'm just gonna count by 5. I'm gonna say, what was this fraction with the multiple of 5? What times 5 is 25? 5. What times 5 is 30? 6. Now I re-examine with the jab, 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 you re-examine. Is there a number that goes into 5 and 6? No. The only number that both 5 and 6 have in common is 1. Therefore, it cannot be reduced anymore. Therefore, it is simplified. That looks really good. So that is 5/6. And the idea with the jab, jab, jab is a lot of the times after you jab once, you'll have to jab again and again until you're like, oh, they have no factors that they have no other factors in common anymore. So then you know it's simplified. What about 6 and 10? These are my favorite because 6 and 10 are even. Whenever it's even, your first jab could be cutting it in half. That would be a 3, and that would be a 5. The reason you can cut it in half is because whenever they're even, you can look at them like their magic number was times 2. Now you look at 3/5. Does 3 and 5 have anything in common? No, they have nothing. They cannot go any smaller. Therefore, that is simplified. So that is your first part. Those are your first challenge questions. Let's go to the next one. Now we're going to add fractions. We are going to add fractions. We have 3 1/3. We have 2 3/4. And we are going to add those together. The first thing you have to do when you add is make sure they have the same name. 3 and 4. Now we're going to take those fractions and find their equal fractions going into that one. So 3 and 4, the first thing they have in common is 12. 3 times what is 12? Times 4. Do it to the bottom, do it to the top. That turns into 4. 4 times 3 is 12. Do it to the bottom, do it to the top. That turns into 9. So now we found equivalent fractions making bigger numbers. Okay. When we simplify, we go the other way. We do this so they have common denominator. 4 and 9 is 13/12. 13/12 is bigger than 1 whole because 12/12 is a whole. So we can pull out 12 and there's still 1 left over, right? 1/12. The 1 flies over to be with all the other whole numbers. So 3 plus 2 is 5 plus 1 is 6. So that answer is not B, but 6 and 1, 12. We have a couple decimals here. We have 587 and 52 hundredths. We have 89 and 23 hundredths, and we are going to subtract. 2 minus 3 is illegal. Borrow. 12 minus 3 is 9. 4 minus 2 is 2. ... 7 minus 9 is illegal. Borrow. 17 minus 9 is 8. 7 minus 8 is illegal. Borrow. 17 minus 8 is 9 and 4. 498 and 2900. And now into the challenge question. If a third of the people at the show are boys and there's 51 people, then how many are boys? So we want to figure out what 1/3 of 51 is. 1/3 of 51. 1/3 of means multiply 51 over 1. First thing you gotta do is turn it into a fraction. 1 times 51 is 51. 3 times 1 is 3. And how many thirds make a whole? 3. So we gotta pull out as many 3s as we can. Sounds like a division problem. So we wanna figure out how many 3s are hidden inside of 51. First thing you do is go into the tens place. You can pull out one group. What's left over? 2. Nothing's left over. 17 is your answer. Mr. Stahl, I cannot divide like that, is what probably at least a third of you are saying right now. We will get into division more and more and more and more, okay? So your challenge question is, 17 are boys. So today for review, there's going to be 3 main focuses. Okay, we're going to focus on 3 major things. I'm going to focus on how to turn an improper fraction into a mixed number. I'm going to focus on reviewing how to simplify a fraction. And today we're going to focus a little bit of time on how to reduce or simplify fractions before you multiply them and then multiply them. Okay. I'm asking you 3 questions per for this review, and then I'll give you a little bit of a homework, and we'll work on that together during your Zoom. So, first thing, we are going to take this and turn it into a mixed number. So, the name of this fraction is 5. That means it takes 5 pieces to make a whole. How many pieces do we have? We have 23. That's our number, right? What do we have? 23 fifths. It's like having 23 chicken wings or 23 bikes or 23 whatever. This is just its name. The name tells us how many pieces it takes to make a whole. But we have more than it takes to make a whole. So we could make some wholes. That would turn it into a mixed number. So let's look at what fifths look like. That's what fifths look like. So we have 1/5, 2/5, 3/5, 4/5, 5/5. What? 1, 2, 3, 4, 5. Those are not fifths, Mr. Stahl. You took pictures of sixths. You jack wagon. All right, let's pretend they're fifths. That's 5. One hole would be 5/5, 10/5, 15/5, 20/5. So 4 holes. Remember, we're pretending these are fifths. Man, I really messed that one up. For 4 holes would be 20/5. That would be 4 holes. So this turns into a 4, and then what's left over? Well, since it took 20 to make 4 holes, there's still 3 left over, which is not enough to take another hole. So 4 3/5 is that answer. Let's make sure I did this again. I bet you I did. Oh, wow. Let's make 11/5, okay? Or I'm sorry, we have 11/5. Let's make them holes. So I'm not even going to use that graphic because I know it's sixths again. I should have counted it better. This is how you really figure it out. You say, this is my name, and I'm going to pull my name out as many times as I can. So I know I could pull out one group of 5, and I know I could pull out 2 groups of 5 because I'm counting by 5s, and 2 of them is 10. Is there anything left over? Yeah, if it's 10, I have 1 left over. So that's a hole. That's a hole. My answer is 2 1/5. Nope. We're not looking at sixths. Again, Mr. Stahl. Come on, man. All right. Now this one I actually counted. I had to find sevenths. It was a little harder than Googling fifths because I just trusted that it was fifths. So we have 18 sevenths, right? So this is what a seventh looks like. How do we know? Because it takes 1, 2, 3, 4, 5, 6, 7 to make a hole. So if we have 1 hole, that's 7 sevenths, but we have 18 of them. So after making 1 hole, we can make another hole, right? 7. Actually, let's put our holes on top. So we have 7 sevenths and 7 sevenths. That is 14, right? And then after you have 14, we still have number 15, number 16, number 17, and number 18. So there were 4 left after making 2 holes. So it's 2 holes and 4 sevenths. 2 and 4 sevenths. And remember, the way that we do that is we count by sevenths. We say 7, 14. We can't go 3 because that would be 21. So you put 2 down. That's 14. 15, 16, 17, 18. There's 4 left. 4 what? 4 sevenths. So that's how you come up with your answer. All right. How to simplify? So on the top, we got jab, jab, jab going on. So there's 2 ways to do it. We could jab, 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 or we can go with the 1 punch out. Let me show you the 1 punch out first. We say, we got to figure out all the factors of 12 and all the factors of 36. So the factors of 12, numbers I can count by that makes 12. Well, every number has 1 and itself. So 1 and 12 are both factors of 12. What about 2? Oh, check this out. I have a poster of all the factors. So 1, 12, 2, and 6, and 3 and 4. I can't count by 5s. I can't count by 7s or 8s or 9s or 10s or 11s. Those are the things I can count by to make 12. So let me write all those down. What about 36? Let's come up with all the factors of 36. 1, 36. 2, how many 2s? 18. 3, how many 3s? 12. 4, how many 4s? 9. 5, no. 6, how many? 6. Okay, so those are all of them. Does this take a while? Yes. Now you got to stare at them and say, what's the biggest factor they both have? 12. That has a 12. That has a 12. So now you got your knockout punch. Your knockout punch is 12. You put times 12 times 12 on this side. You say, what times 12 is 12? 1. What times 12 is 36? 3. So that answer is 1/3. But Mr. Stahl, is there an easier way? Is there an easier way to do this? Yes, there is. I think there is. All right, let's look at 1236 again. See how they're both even? If they're ever both even, cut them in half. The smaller the number, the easier to work with. So cut them in half. We have 6/18. Oh, they're still even? Oh, cut them in half again. 3 9s. Are they even? No. Are we done? I think so, right? Oh, I can count by 3s for both of them, right? I can count by 3s. 3 and 3, 6, 9. So it's 1/3 because it takes 1 3 and it takes 3 3 or 3 3s to make 9. So look, either way you go, you get the same answer, 1/3. Which method do you like better? Okay, remember these are ors. You're like, I gotta do both of those? No, you choose which one you like better. Do you like the jab, 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 or do you like the one punch knockout? So here is a list of all the equivalent fractions to 1/3. See, and that's not all of them, right? 100, 300, that makes sense? And it goes on and on and on and on. So what we did was we had an answer that was here, and we wanted to backtrack until we figured out what the smallest equal fraction is. Yes, that is my daughter in the background. All right, we got 2 more, and then we are finished for the video. We have 22/38. 22/38. You guys like the jab, jab, jab? Me too. I like the jab, jab, jab. So let's do the jab, jab, jab. Hold on 1 second. So they're both even. That means cut them in half. What's half of 22? 11. What's half of 38? Okay, so half of 30 is 15. Half of 8 is 4. So add those together, it's 19. Are we done? Well, 11 is a prime number. That means the only 2 factors of 11 are 1 and 11. So 11 has to go into 19. No, it doesn't. Not perfectly. You can't count by 11s. Therefore, there's nothing smaller you can do. 11/19 is the answer there. And then last one, we have 18/35. We have 18/35. Now, see how they're not both even? See how nothing stares at you like, oh, snap. You can use that. So what we do here is I just say, okay, look at the smaller number. Find all the factors of the smaller number. 18 smaller. So it has 1 and 18, 2 and 9, 3 and 4. I lied. 3. How many 3s make 18? 6. And then 4, no, 4 doesn't go into it. So those are all my factors of 18. So now I say, can I count by 18s and hit 35? No. Can I count by 9s and hit 35? No. Can I count by 6s? No. Can I count by 3s? No, because 3 times 11 is 33. Can I count by 2s? No. Can I count by, well, 1s doesn't change anything. So that was a trick question. That one already is simplified. All right, so now we're going to reduce before we multiply. We're going to reduce before we multiply. Okay, check this out. I can reduce both of these by 5s. I could turn that into a 1, and I could turn that into a 2. Now, can I reduce these? No. Can I reduce these? No. So I multiply across. The answer is 4/15. And that is already simplified. The other thing you could have done is you could have said, where am I at here? You could have said, oh, let's count by these, let's count by 5. And you could have multiplied across. Then you still would have got 4/15. What about here? They both have 3 in common. I can cut those down. Oh, yeah, that's perfect because I'll cut these down by 10s. So that would be 1 10, and that would be 2 10s. And I'll count these down by 3s. How many 3s make 15? Or how many 3s make 12? 4. How many 3s make 15? 5. Now you multiply across. 4 times 1 is 4. 5 times 2 is 10. Oh, they're both even, so I got to cut them in half. Your final answer is 2/5. And then what about here? Last one, for real this time. No, 2 and 3 can't get reduced. 7 and 21 can. So let's count by sevens. This would take 1. This would take 3. Now multiply across. 2 times 1 is 2. 3 times 3 is 9. That answer is 2/9. Now remember, if you're like, I have no idea how you pick those two, there's all different options. If you just multiplied across and you would have gotten 14, right? And then 3 times 21 is 63. And you would have been able to reduce that, okay? By what? Well, let's see. We can do sevens, right? How many sevens make 14? 2. So the magic number of 7. And how many sevens make 63? 9. So once again, different route to get to the same answer. All right, ladies and gents, that concludes this video. So now you just have to work on your Google Doc that I sent to Tomer, and we will work on that together during our Zoom. All right, thank you for participating.